So the next one we're going to look at is an alternating series test. An alternating series has the form that it changes sign every time. In order for an alternating series test to converge, we need that it is decreasing. In other words, term a sub n plus 1 must always be less than term a sub n for all n, and that the limit as n goes to infinity of a sub n must be 0. So let's look with this example. This is one that we had come across in a previous video, and we applied the absolute value test to find that it was inconclusive, which told us that there's no way it can be absolutely convergent. Let's see if it is conditional, what's called conditionally convergent, or for right now what we're just calling convergence. So the alternating series requires two things. One, we have to have all positive terms for what the a sub n part is. I'll bring that back over here in a second, and so you can. The a sub n part is the part that does not include the alternating piece. So the way it's written up, if you remove the alternating piece, a sub n is what you have. So we need it to be decreasing, and 2, we need the limit as n goes to infinity of a sub n to equal 0. So for our series there, a sub n is 1 over n. So we need to show that it's both decreasing and that its limit goes to 0. So let's take part 1 first. We need to show that a sub n plus 1 is less than a sub n. So we need to show 1 over n plus 1 is less than 1 over n. Do this similar to how we would do the comparison test. We want to show this. All our terms will be positive, so I'm not going to worry too much about 0. But so that means if I work backwards, that means n plus 1 versus n. Flip that. N plus 1 is greater than n, and that's true for all n greater than or equal to 1. So 1 is checked out. It is decreasing. Number 2, the limit as n goes to infinity of 1 over n equals 0. Checks. So our series negative 1 to the n over n is convergent by the alternating series test. Now, just because it's one that I've had in my previous couple other videos, we had one that looked like this: cosine of n over 2n squared plus 5. That is not an alternating series, so this test would not apply. Now, contrast that with cosine of pi n. This is an alternating series, and a sub n for this one is 1 over 2n squared plus 5. And it's not too hard to show these two parts for a sub n here. This makes it alternating. This is the piece that makes it alternating here. So all I have to do is show that this is decreasing. So, and it's not too hard. I'll leave that up to you. But we would show that a sub n plus 1 is in fact less than a sub n. And 2, well, you guys can probably see it already. The limit as n goes to infinity of 1 over 2n squared plus 5 equals 0. So this would be convergent by the alternating series test. The other one was not an alternating series, so we cannot use the alternating series test. We ended up using the absolute value test to show that one, when there wasn't pi in there, to show that was convergent. You can see that in one of the other videos.